Alright, boys and girls, welcome back to Rock the JVM. I'm Daniel, and in this video I'm going to show you refined types in Scala. Now, this video is for Scala programmers of all levels, but the most advanced programmers will get the most value out of this video, especially if you watch the type level programming mini-series which I recently published. So check out the Rock the JVM channel or the type level programming mini-series where we exploit the power of the Scala compiler to validate relationships between types at compile time. So this is pretty magical. However, it will not impair your ability to get value out of this video, so feel free to continue watching as well. Now, as always, I'll recommend that you code with me, and whenever you need to refresh your memory about this topic, about refined types, just refer back to this video or to its written form at rockthejvm.com/blog with the link in the description. Alright, so with that being said, let's get back to our development environment where I've created a small object that I call refined types, and I'm going to also add a main method here in IntelliJ just in case we need to test anything. But most of the situations that we're going to demonstrate will happen at compile time. Now, in the meantime, if you want to add the refined library that we're going to use in this video, go to your build.sbt and add this library over here, eu.timepit %refined, and the version that I'm going to use in this video is 0.915, but you can use a later version of the refined library, and I'm going to attach the link in the description of the video. Now, let's get back to our code. So what's the goal of this video? What is the problem that we want to solve? Now, in our Scala experience, we often work with data that causes us lots of problems. For example, negative numbers or empty strings or emails that don't contain the @ sign and so on and so on. Now, to handle these kinds of data, these kinds of values, we usually write a lot of defensive code so that our application doesn't crash at runtime. Now, the problem is that very often such problems can be avoided altogether before the application is even compiled. So, say we're writing a distributed chat application and our users are signed in via their email, and I'm going to define a case class that I'm going to call user with name as a string and email as a string. Now, if you write something like this, it's very easy to create user instances with valid data, like let's call this Daniel as user with the name Daniel and email daniel@rockthejvm.com. Alright, so this is pretty easy, but when someone else creates this type, for example, in a some kind of domain model part of the code, and you want to instantiate your user, we can be sloppy or innocent and forgetful and forget the order of these fields. So for example, I can say, let's call this invalid Daniel as user with these fields swapped. For example, Daniel@rockthejvm.com and the name Daniel. And this is perfectly applicable, this is perfectly compilable, and this is also wrong at runtime, all right? So when you write something like this, it will probably cause problems when the application actually runs. And to compound this issue, when you have some object functional mapping, for example, you are mapping a user definition from your database, these fields might sound like V1 or V2 or something like that, and it might cause additional confusion when you forget what each of these fields mean, all right? Now, we can also create some validation logic around these so that we don't pass invalid information for their respective fields. So some potential workarounds for this kind of situation would be to say validate logic at creation time, use value types. So value types are classes that extend any val that box a single value, for example, a string, with some additional logic, or to, for example, create smart constructors like user.new instance with name and email with additional validations. But none of these prevent the application from actually crashing at runtime. And so the refined library that we're going to explore in this video is a small library for Scala that wants to help us avoid this kind of preventable crashes at compile time. So before the application actually starts. We can leverage the power of the Scala compiler to validate certain predicates before our application has a chance to run and ruin our day. So let's start with something very simple. Say we want to test positive numbers. So we want to create an application that only accepts positive numbers. But there's no such thing as a positive integer type, because the int type in Scala obviously covers minus 2 billion to 2 billion, right? So we can use a refined type over int to enforce that the number is positive. And for that, we will import some additional packages. So I'm going to import EU timepit refined API refined. So refined will be a type that will impose some type level constraints. I'm also going to import EU timepit refined auto, and this is used for implicit conversions, and IntelliJ is not even IntelliJ is smart enough to suggest this this package for you. So this will be for implicit conversions. And I'm also going to import EU timepit refined numeric. So these are refined numeric types, or should I say predicates. And I'm going to demonstrate the validation of a number being positive at compile time by saying something like this. I'm going to write a val. I'm going to name this a positive integer. And instead of int, what I would normally say equals 42, I would use this new refined type. So I'm going to say refined. And refined takes two type arguments. The first is the type of the value that you want to use, in our case int, and the second type is the predicate type. And the predicate type is going to be positive. So positive is a predicate type which imposes a type level constraint over a type that derives from int. And the magic behind this line over here is pretty complex, but it involves macros plus implicit conversions. Now notice that after I wrote this line, all these three imports lit up, and that will happen because if I run this application or if I hit compile, this code should compile just fine. And naturally, because we don't have anything in main, we don't need to print anything. But if on the right hand side of the equal sign I pass in a number that is not positive, so I'm going to define an invalid integer as refined of int and positive, equals, and on the right hand side I put in negative 100, IntelliJ doesn't catch this error, but if you go to build and then recompile, you will get a compiler error. And the compiler error will be also very descriptive. Predicate failed, negative 100 needs to be bigger than 0, which obviously is not the case. So this, in a nutshell, is the main benefit of refined, the refined library. It helps the compiler catch your errors before you even deploy your application. I might talk in another video about how this refined library actually works with macros plus implicit conversions. It also uses the shapeless library behind the scenes, but this is probably the topic of another video. Now that you're more familiar with the problem and how this refined library solves it, let's go over some of the capabilities of this library. Now I'm going to go over the most useful of them. So you saw this numerical positive predicate. There are tons of other numeric predicates, for example, to allow only negative numbers as refined with int and negative as negative 23 or something. I'm also going to comment this out because otherwise the code will not compile. You also have non-positive to also include 0. You have non-negative to also include 0 and all the positives, and so on and so forth. So you have positive, negative, non-positive, and non-negative to validate the relationship between these numbers and 0. You also have predicates for odd numbers and even numbers. So I'm going to define an even number as refined between int and even. So even is also a type level predicate that will catch your errors if this literal over here that you write on the right hand side is not divisible by 2. So this will be the even predicate. And as was the case for positive, it's detectable at compile time. Now, just as syntactic sugar, you can also use refined because it takes two type arguments. You can use that int fix, so you can use int refined even, which is exactly the same as saying refined between int and even. And this is identical code. So this is a syntactic sugar for infix types. Now, I'm also going to show you some more complex, more powerful type level predicates for numbers. For example, I'm going to allow numbers less than a certain value. This is possible at compile time with the magic provided by Shapeless and the macros that it adds. So I'm going to use an import EU timepit refined W, and W is an alias for shapeless.witness. And shapeless.witness has some macro magic that will create some types before the code is compiled. So this is a type generator for us, and I'm going to define a value. I'm going to call this small enough, and I'm going to mandate that this integer be less than 100. So I'm going to say int refined, and on the right hand side of the refined, I need to pass in the predicate, and the predicate from refined is called less, and less takes a type argument in, which can be automatically generated by this witness. And the structure here is a little bit more, let's say, weird, and I'm going to say w dot, and I'm going to open and close a backtick, and between these backticks I'm going to pass a value. So I'm going to say 100. So I'm going to mandate that this number is less than 100 by creating a type programmatically by saying w dot backtick 100 dot t. So dot t is a type member of this witness thing, and this w dot 100 dot t is a type that refined understands. And on the right hand side of equals, I'm going to say 45. And if 45 is less than 100, then this code will compile. If I say 450 and I hit recompile with my keyboard shortcut, then the compiler will not compile our code. Predicate failed, 450 less than 100. All right, so this was the predicate that failed. So this is how you can create types at runtime with the shapeless witness in the style that refined understands. So you can say w dot backticks, and then you can pass in any value, and the witness will take care to automatically create that type for you via macros. All right. This is pretty magical. I'm going to talk about shapeless in another video. Now, given all this power, you can also create predicates here that will validate numbers at compile time, for example, less than 100 or greater than 100 or less than equal or greater than equal. And you have other functionalities which are also unlocked by this witness thing. For example, saying that it's in an open or closed interval. So I'm going to say 0 to 100 as of type int refined. And I'm going to say open, closed. And open closed takes two type arguments. The first is a number, and the second is also a number. So I'm going to say w0 and w100. And on the right hand side, I'm going to say, for example, 56. And open closed here means an open interval on the left hand side and closed interval on the right hand side. So in the math sense, that means the number must be strictly greater than 0 and less than or equal to 100. You can use open to be open at both ends, or you can say closed to be a closed interval at both ends, or you can say closed open to be closed on the left hand side and open on the right hand side. And you can import every single type by importing the appropriate interval over here. All right, so I'm going to use open closed as I wrote earlier. Good. So this is how you can mandate that a number be between two numbers. You can also have some more interesting predicates, for example, that the number must be divisible by another number. So I'm going to say divisible by 5 as of type int refined divisible with, and I'm going to paste here the expression w, let's say 5t as the value 25. And if 25 is divisible by 5, then that means the code will compile, otherwise the code will not, and so on and so forth. There are many filters that you can apply at compile time for integers, but these are the most common and the most useful. Again, all of these happen at compile time, so you can validate all these numbers before your application is even deployed. Now, The most useful validations will happen on strings, actually. Since so much of our application logic is dependent on strings, it makes sense to want to validate them in various ways. So for strings, by far the most useful filters are ends with, starts with, and regex matching. So I'm going to say import EU timepit refined string underscore, as we did earlier with numeric, and I'm going to define a refined string. So for example, I'm going to mandate that a string must end with a certain character. And I'm going to use the example of a command prompt, which in most terminals ends with a $sign. So I'm going to say command prompt as string refined with the following predicate, ends with, and notice that ends with a type argument s. And if you want to end with a character of your choosing or with a string of your choosing, you would have to follow this pattern as well. So you'd say w.backticks, and inside you would pass in a string, in my case $, and then do a .t. So this is the type member of this new type. And on the right hand side, I'm going to put in a string like Daniel at mbp my computer, and then a $sign to validate that. And if you go to build and then recompile, you will validate that this string ends with that $sign. Okay, good. Now, if the string doesn't end with a $sign, naturally you'll get into a compiler error because the predicate is not satisfied. So Daniel at mbp does not end with a $sign. So you get the idea. Now, Regex is, or Regex, depending on how you want to pronounce it, is probably the most powerful because the library allows you to test both whether a string is a regex and if a string matches a regex. So I'm going to define a val called isRegex as string refined regex. So regex doesn't take any type argument, it's a predicate in its own right, and I'm going to pass in a regular expression. For example, I'm going to say regex, and inside parentheses I'm going to say x or es question mark. Right? So regex or regexes, or however you want to define plural here, regexi. You get the idea. I never actually put any thought in pluralizing regex, but you get the point. So this predicate over here tests whether the string on the right hand side is a proper regular expression. Now, if you want to have a string match a regular expression, you will define, I'm going to define a type alias here because the type is probably going to be pretty long. I'm going to type email as string refined. And if you want to add a predicate for a string to match a regex, you would say matches regex, and then you would pass a regular expression here as a string, again with this pattern that you saw earlier. So I'm going to say w backticks string t, and inside the quote you would pass in a proper regular expression. So I'm going to use a triple quote so that we don't escape too many characters, and I'm going to define a very simple regex matching emails. I'm pretty sure it's not the most accurate, but it's probably the most simple to understand. So AZ09 plus, so this is the first name, and then at, and I'm going to pass in another AZ09, and then I need a plus, so this will be Daniel at Rock the JVM, and then a dot. So I'm going to use a backslash dot, and I'm going to escape the backslash as well. So backslash dot, and then I would use com. So I'm going to say AZ09, and then repeated by at least 2 times. So this is going to be the domain, and I mandate that this character is repeated twice. Now, I'm pretty sure that this regex doesn't match all emails. For example, an email that has a dot in it will not be matched, but whatever, I don't really care about that. So you get the idea. You can pass in any kind of regex that you want, and I'm going to use that to validate that an email matches my regex. So I'm going to say val, let's call this Daniel's email, of type email, and on the right hand side of equals, I'm going to say Daniel at rockthejvm.com. And if you go ahead to build and then say recompile, then this code should compile if the regex was good. It'll take a bit of time. But lo and behold, my email compiled just fine. So this is how you can mandate that a string will match a regex of your choosing, and you can pass in any kind of regex that you want. So to solve our problem above, where you would have a user with a simple name and a simple email, you would define these type aliases like type email and type name as string refined matches regex. And let's say that my simple name needs to start with a capital letter and nothing else. And I'm going to say W backticks triple quote string, and inside I'm going to say AZ, so this is the first letter, and then AZ plus. Okay, and then finally I'm going to say .t, and this is the refined string type for my name. And if I want to create Daniel's name of type name as Daniel, the code should compile. And if you want to solve the original problem with the name and email being interchangeable, you would define a case class that would actually use these refined types. So I'm going to say proper user, or let's call this refined user, with a name as a name and an email as an email. And in this case, you will have the predicate validations here at compile time when you pass these names. So I'm going to say val, let's call this Daniel refined, as a refined user with Daniel's name and Daniel's email. All right. So when you compile this code, if it runs, then that means that your types matched the predicates correctly. It'll take a bit of time. All right, good. So we have the code compiled just fine, and we should be ready to go and use this case class wherever is relevant for our application. Now, the final thing that I want to show you is how to refine values at runtime, because granted, we can't work with these manually inserted literals all the time, probably not even most of the time. So the refined library allows you to put a value through a predicate and return an either, which contains either the string which describes the error of predicate matching, or the refined type. So I'm going to show you how to refine at runtime. And I'm going to add another import here, EU timepit, refined, API, ref type. So ref type has an API that will allow you to put a value through a refined predicate. So I'm going to define a val, let's call this poor email, which obviously doesn't match the predicate of an email. So I'm going to simply say Daniel, not having an @ sign there. And I'm going to define another value called refine check as ref type dot apply ref, and apply ref takes a type argument here, which is my refined type. So I'm going to say apply ref with email, and this is my refined type over here. Now I need to also apply that to the string that I want to pass through. So I'm going to say poor email. Now IntelliJ doesn't correctly show me an error here because it says no implicits found, but if I go ahead and actually recompile this, the compilation will succeed. So I'm going to not get any compiler errors, so just ignore this. And if you want to print line refine check, you will see an either printed to the console. So I'm going to run this application. And notice that we get a left, which contains the error. And the error is a string. Predicate failed, and the predicate that should succeed was Daniel matches this regex, which obviously it doesn't. All right. So when you want to convert a string, a plain string, to your refined type, you could use this apply ref API to convert that value to your refined type. And then with the either instance that you obtain, you can do pattern matching, or you can pass it along as you see fit in your application. Alright, so you've hopefully learned a new powerful tool to test values at compile time and catch nasty bugs before your application is even deployed. If you need some intuition on how refined works, check out the type level programming mini-series which we have here on YouTube as well, with a link in the description. Now, if you like this video, go ahead and click the like button for me and subscribe to the Rock the JVM channel for more videos like this. Now, I'm dying for feedback, so leave your comments. I read every single one, and follow us on Twitter and LinkedIn for fresh updates on upcoming material. And also check out the Rock the JVM website for hundreds of hours of material like this. I'm Daniel, signing off and waiting for you in the next one.